Hello everyone. In the previous lecture we have seen about the center of mass. What is meant by center of mass? आपण previous lecture मध्ये पाहिलं होतं की center of mass कशाला म्हणतात? The whole mass of the body is supposed to be concentrated at one point. That point is nothing but the center of mass. Today we see the example depending on the center of gravity. Center of gravity म्हणजे काय? आपल्याला माहित आहे की अर्थवरती काय असतं, ग्रॅव्हिटेशनल फोर्स असतो. सपोज वी कन्सिडर द मासेस हँडेड अपॉन एनी सपोर्ट. ठीक आहे, M1 M2 M3 असे मासेस घेतले आणि ते हँग केले एखाद्या सपोर्टला, तर ते काय होतील, खाली त्याचं प्रेशर जास्त असेल ड्यू टू ग्रॅव्हिटेशनल फोर्स. मीन्स त्याचं टोटल ग्रॅव्हिटेशनल फोर्स काय येईल, M1 G1 M2 G2 M3 G3 and M4 G4 and so on. Means on the earth there is a availability of gravitational force, that is the center of gravity. Now depending on the center of gravity we see one example, that is two brass spheres of radii 5 cm and 10 cm are brought in contact with each other. Find the center of gravity of the combination. Here आपल्याला काय विचारलं आहे इथं, सेंटर ऑफ ग्रॅव्हिटी. डाटामध्ये काय दिलेले आहे, रेडियस ऑफ वन स्पियर अँड रेडियस ऑफ सेकंड स्पियर, दॅट इज R1 is equals to 5 cm and R2 is equals to 10 cm. Here we consider two spheres coincide at one point. That point is taken as origin O. The C1 and C2 be the centers of sphere first and second respectively, and R1 and R2 are their radius. Okay, then for the center of gravity we know that mass of the first sphere is considered as M1 and mass of the second sphere is considered as M2. Here we denote mass of the first sphere is M1 and mass of the second sphere is M2. For the calculation of center of gravity we have to calculate the mass of the first and second sphere, because for the position vector there is mass is necessary. Now mass of the first sphere is denoted as M1, volume into density. We know that volume of the sphere 4 pi by 3 into R1 cube. 4 pi by 3 is the standard value and R1 is radius of the first sphere. The radius of the cube of the radius means 4 pi by 3 into R1 cube is our volume of the first sphere, and density is denoted as notation rho. This is called as rho. Okay. Now similarly mass of the second sphere M2 is equals to 4 pi by 3 into R2 cube into rho. Means M2 is 4 pi by 3 into radius of the second sphere. The cube of radius of the second sphere is our total volume, and into rho means density of the second sphere. Position vector of M1 is equals to minus R1. We know that here R1 bar and R2 bar be the two position vectors of sphere first and second respectively, but here we take position vector of the first sphere as minus R1 because it is directed along the center of the sphere, and R2 is taken M2. पोजिशन वेक्टर ऑफ M2 मीन्स या स्पियरचं जे मास आहे त्याची रेडियस काय असणार आहे, R2, अँड फर्स्ट स्पियरची काय असणार आहे, मायनस R1. द पोजिशन वेक्टर ऑफ द सेंटर ऑफ मास R bar is denoted by R bar, capital R bar. We know that position vector is the product of the mass and the position vectors of two spheres and addition of that masses of the two sphere. Here taking the values M1 into minus R1 vector plus M2 into R2 vector upon the addition of these two masses is taken as M1 plus M2, that is our position vector of the center of mass. Now capital R is equals to R1 cube into minus R1 vector plus R2 cube into R2 vector upon R1 cube plus R2 cube. Here position vector of the mass M1 is taken here as R1, therefore we put here value the R1 bar, R1 क्यूब अँड m2 ची व्हॅल्यू काय घेतली आहे आपण r2 क्यूब. हिअर सिमिलरली m1 and m2 r1 cube plus r2 cube. These two vectors are directed along the same line. Okay, here distance of center of mass from O. Here we know that these two spheres coincide at one point. That point is taken as point O. Therefore distance of center of mass from O means आता आपल्याला काय काढायचं आहे की डिस्टन्स ऑफ सेंटर ऑफ मास फ्रॉम O. या पॉइंट पासून सेंटर ऑफ मासचं डिस्टन्स किती आहे दॅट कॅन कॅल्क्युलेटेड ॲज RCM. R means position vector of the center of mass and CM denotes the center and M mass. Okay, is equals to R2 raised to 4 minus R1 raised to 4. Here the calculation of powers will be R2 raised to 4 and minus R1 raised to 4. The minus, this minus is taken as here, therefore R2 raised to 4 minus R1 raised to 4 upon R2 cube plus R1 cube. Here we taken as R2 term first and minus of R1 is secondly. Therefore in the upon term we take similarly R2 raised to 3 plus R1 raised to 3. Then is equals to RCM is equals to 10 raised to power minus 1. The power of 10 raised to power minus 1, 4 minus 5 into 10 raised to power minus 2. The whole power is 4. Here the term 5 centimeter and 10 centimeter are in centimeters. Therefore we have to convert that in meter as here centimeter, and R1 is equals to 5 into 10 raised to power minus 2 meters. This is the conversion of centimeter to meter. Here we take this term 10 raised to power minus 1 raised to 4 minus 5 into 10 raised to power minus 2. The whole power is 4. Similarly 10 raised to power minus 1, the value of R2 and the value of R1. Okay, now the substitution of this will get 10 raised to power 4. The 10 raised to power minus 1 terms are cancel each other. Then remaining terms are 10 raised to power minus 4 minus of 5 raised to power 4. The whole power is 4 and 10 raised to power 3 plus 5 raised to power 3. RCM is equals to 10 raised to power 4 minus 5 raised to power 4. Okay, here 10 raised to power 4 means 10,000 and 5 raised to power 4 means 625. In the 10 raised to power 3 plus 5 raised to power 3 means 10 raised to power 3 means 1000 plus 5 is a cube means 125. The subtraction will be 9375 and the addition of these two will be 1125. Okay, this term is reduced will be 375 upon 45. आता याला कशाने डिवाइड करायचं आहे आपल्याला 15 नी. तर आन्सर काय येईल आपला 25 divided by 3. 15 3 is 45 and 15 25 is 375. This is our radius vector of center of mass from the point O. Okay, thank you.